Are we ready to do some more Algebra 2 on crack, kids? Okay, so first one, supposed to find velocity. Wait, I know how to find velocity. That's just the first derivative, Torres. You're not even making this hard at this point. Girl, please. So silly of you. Look, there's my velocity. Then it wants to know what's the velocity after 2 seconds. Huh, I wonder what I should... Genius. See, I know you're shouting out the answers there in your room without me. Oh, wait, I'm with you, I'm with you. So we're going to plug in 2. And then I'll probably need a handy-dandy calculator to work that out safely. I got, wait a second. 12 minus 24, negative 12, plus 9 is negative 3. Wonder what that tells me. And by the way, this is meters per second. What does that tell me about the velocity if it's negative? I have 2 choices. Since it's moving in a straight line, I'll assume that straight line is probably horizontal. And so if that straight line is horizontal, then a negative 3 would indicate that I'm moving backwards. This is you backing up in the car. Don't go negative 3 meters per second. So if my particle is at rest, what would that tell me about velocity? You're right, it has to be 0. So I'm going to take my velocity and I'm going to set it equal to, see, I don't even think you need me, you guys are just too smart now. And I'm thinking I can probably take a 3 out of this, which will make it much easier. And then I'm always already thinking, I wonder what it factors to. Of course, it's not going to factor at all if I don't put in the right numbers. Ay, ay, ay. I know you were probably yelling out Scooby Snack, weren't you? You head off to the kitchen and get yourself a Scooby Snack because you caught that mistake if you saw it. So I have t is going to be equal to 3 and 1. So now, when I want to know when it's moving forward, that of course would tell me that my velocity, if it's moving forward, has to be positive. And that's what that just says in symbols. And so the first thing I would do is figure out, well, when is it actually 0? Well, we just did that. We found those 2 values where it's 0. So I would put them on a number line, and then I would try some numbers. So in this left section, I don't know, maybe I'd try 0, and in here I'd try 2, and in here I'm going to try 4, and I'm going to plug them into the velocity. I'm going to plug them into here, aka I'm plugging them all the way up in here to check to see if they're positive or not. So let's see, if I try 0 and I plug it in, well, all the terms are going to cancel out except for the 9, so that'll be positive. Oh, well, I definitely want to keep that then. If I try 2 and I plug it in, well, I already know what that happens. I get a negative 3, right? Because that was up here in this answer. So I don't want that, because that means it's moving backwards. And if I try 4, I'm going to have 48 minus 48 plus 9. I'll have another positive 9. So I definitely want to keep all of that. So it's moving forward now. Of course, remember, t is time, so I have to be greater than 0. So it's moving forward from 0 to 1, and from 3 until I don't know what happens at this point. So I'm just going to put to infinity. That's relatively simple, Torres. So if I'm trying to find total distance, of course, I need to be looking at the position function. So I want to be using s of t. But here's what I have to remember, is that when that object is moving backwards, if you go backwards, let's think about you running backwards for the Grizzly Mile. If you go backwards, that's kind of like negative distance. So what happens when I add positive distance and negative distance together is they cancel each other out. So I'm going to need to make sure that I absolute value the distances. So now that I've figured out when it's moving forward and when it's moving backward in the last problem, I'm going to section that off and look at those distances separately. And of course, total distance would mean I'd have to take however much I started with and subtract however much I end with.